Hello everyone. Today let us learn about units. In the 11th standard, as soon as you enter into the 11th standard in physics, you will learn units and dimensions. It is very important to know about the units. In everyday life, we whenever we buy something, we pay amount of money in rupees and we buy the different quantities depending upon their units. For example, when we go to market and buy vegetables, we ask for 3 kgs of potatoes, 5 kgs of tomatoes, 1 kg ladyfinger, 1 kg brinjal, etc. And when you go to petrol to fill your car, when you go to the petrol shop to fill your car, we ask for 5 liters of petrol, 10 liters of petrol, etc. And whenever we go to a clothes shop to get stitch something our clothes, and we ask for 2 meters of cloth, 5 meters of cloth, etc. we ask. So these are nothing but units. The kg, meter, liter are the units. These are the main units which we are using in everyday life. When a milkman comes to our house, we ask for 2 liters of milk. We don't ask for 2 kgs of milk. It is wrong. Nobody measures milk in kgs. We measure the milk in liters. So, liter is a unit for milk. Like that, we have different units. We have different units to study. So, let us see what are these units, and also we will learn about the measurements. Measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard called unit. Measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard called unit. This is a big sentence. In simple words, if you want to understand, measurement of any physical quantity. So, like for example, if you want to buy milk, that is a physical quantity. How you will ask for milk? You will compare it with a certain basic unit that is nothing but liter. But that liter should be accepted by international standards. It should be internationally accepted. Then only it is valid. So the liter, kg, meter, second, and these are all the units. So we will learn about units. Mainly in this particular topic, we will learn about units. We have a very large number of physical quantities. Many quantities are there. So we measure length, mass, time, and we measure velocity, acceleration, force, energy, power, and so on. Many quantities are there, physical quantities to measure. But a limited number of units are needed to express them all because they are interrelated with one another. For example, I tell you, to measure the distance we use meter, and to measure the time we use second. Therefore, the measurement of velocity is second. Meter per second. That means they are interrelated with one another. That means the length is measured, that means the distance is measured in meters, and time is measured in seconds. Mixing those two units together, we measure the velocity. Similarly, we mix meter and second and we measure acceleration as meter per second square. The units for the fundamental or base quantities are called fundamental or base units. There are certain quantities called as fundamental units. There are certain units which are called as fundamental or base units, which measure base quantities. So the units for the fundamental or base quantities are called fundamental or base units. So there are certain units which are used to measure fundamental quantities or base quantities. The units of all other physical quantities can be expressed as combinations of the base units. As I told you, velocity is a combination. Velocity SI unit is a combination of meter and second. The SI unit of velocity is a combination of meter and second. Such units obtained for the derived quantities are called derived units. In this example, meter, which I told you, is a base unit. Second is a base unit, but velocity unit is derived, therefore, meter per second is a derived unit. So, whenever you take units derived from the other base units, we call them as derived units. A complete set of these units, both the base units and derived units, is known as system of units. A complete set of these units, so those units can be base units or those units can be derived units, completely all of them together, we call them as system of units. Now, the international system of units, it mainly it mainly consists of three main systems which are used extensively are CGS, FPS, MKS. The three main systems which are widely used are CGS, FPS, and MKS. The base units for length, mass, and time in these systems are as follows. CGS, for the first system is CGS. C stands for centimeter, G stands for gram, S stands for second, respectively. The main base units are length, mass, time. The main base units are length, mass, and time. Length, mass, and time. Therefore, in CGS system, for length it is centimeter, for mass it is gram, and for time it is second. Second system is FPS system. In FPS system, for length we measure in foot, for mass it is found, and for time it is second, respectively. And coming to the MKS system, which is most widely used system, in this, to measure the length we use meter, to measure the mass we use kilogram, and to measure the time we use second, respectively. The main system which is widely accepted internationally is SI system. SI system is most widely used throughout the whole world. SI, it is actually a French word, System International, D unites. French word for this international system of units. And in SI system, there are 7 base units as shown in the following table. The first one is length, and then it is measured in meter. The symbol is small m. The second one is mass. It is measured in kilogram. Symbol is kg. The third one is time. It is measured in second. Symbol is S. The fourth one is electric current. It is measured in ampere and its symbol is capital A. The fifth one is thermodynamic temperature. It is measured in Kelvin. The symbol is capital K. The sixth one is amount of substance. The name, the unit is mole, and the symbol is MOL, small letters. The seventh one and the last one is luminous intensity. It is measured in candela, that is, symbol is CD. Mole is generally used to measure the chemical elements and compounds, and luminous intensity is generally used to measure the intensity of light. And the remaining things most of you know from your previous classes. Thermodynamic temperature is measured in Kelvin, current is measured in ampere, time is measured in second, mass is measured in kilogram, and length is measured in meter. Besides these seven basic base units, there are also more units that are defined for a plane angle and a solid angle. The mainly seven base units are there, as we have seen in the table. In addition to those seven units, we have two more two more units. Number one, plane angle. Number two, solid angle. The plane angle, as you can see here, the angle between two lines which are joined at O. Two lines are joined at O, and the angle between them is d theta. If you can look at that figure, it looks like the d theta is the angle between two radii of a circle. It appears like that, and ds is the and ds is the arc of the circle. Then angle d theta is equal to arc by radius, arc by radius, that is d theta is equal to ds by r, that is measured in radians. So angle d theta is equal to ds by r, that is measured in radian. The unit for a plane angle is radian, and the symbol for that is RAD. The unit for a plane angle is radian, and the symbol for it is RAD. Next, we have a solid angle. To measure the solid angle, we have to imagine like a cone shape. Ice cream cups, ice cream cones are there. And most of us, we like ice cream. Ice cream, sometimes they give in cones. When the cone shape is there, the angle in the bottom, the angle which comes up along with that cone shape, that is called as the solid angle. And the solid angle is measured in steradians. It is measured in steradian. The symbol of steradian is SR. You can see here, they have shown here a picture which is in three dimensional. It is like a cone shape. The solid angle is d omega, and the radius of this cone is r, and the area which is shown like outward area which is on the top of the cone is dA. Therefore, the solid angle d omega is equal to dA by r square, where r is the radius of this cone. Therefore, we can use this SI unit, steradian, to measure the solid angle. To measure the solid angle. So both these are dimensionless quantities. That means if to measure the plane angle, we use radian. To measure the solid angle, we are using steradian. Both radian and steradian are dimensionless quantities. And with this, we conclude our basic base units, and later we will talk about different topics in this chapter. We will see how to measure various quantities like length, mass, time, etc. We will meet again in the next video. Until then, bye. God bless you all. Thank you for watching this video. See you all in the next video. God bless you all.